Hi, it's John here, working through 4Clojure problems. We're on number 53. Longest increasing sub-Seq. Difficulty is hard. And this one was kind of hard. I agree with that. Alright, given a vector of integers, find the longest consecutive subsequence of increasing numbers. If two subsequences have the same length, use the one that occurs first. An increasing subsequence must have a length of 2 or greater to qualify. Okay, so we see 1, 0 is decreasing, then 0, 1, 2, 3 is increasing. It's got a count of 4. And then 0, 4, 5 is increasing, but it's got a count of 3. So 0, 1, 2, 3 is the winner. 5, 6. It's the same as 1, 3, and 2, 7, but 5, 6 came first. We have 2, 3, 3, 4, 5, so 3, 4, 5, and then 7, 6, 5, 4, nothing. It's not increasing, so then basically we end up with the empty vector there. Okay, so I've written down the strategy that I'm going to use here to solve this problem. And what we'll do is we're going to take our input sequence, and then we're going to group it into current and next lists. So there'll be, instead of one sequence, is going to be a sequence of sequences where each subsequence is the current value in the list and the next. It'll be 1, 0, then 0, 1, then 1, 2, then 2, 3. And that way we can start to group it into sequences where the next value is bigger, etc. So we'll once we have these pairwise current and next, then we'll group it into pairs that are increasing. Then we will take those pairs and stick them back into just proper lists of just their elements, single wise, and then we'll have to add in the highest value. Basically, the next value will go on to the list. Since essentially what's going to happen is once we break this up, we'll have 1 as a certain list, and then 0, 1, 2 is a certain list, and then 3 is a list, and then 0, 4 is a list, and then 5. And what we need to do is take this 0, 1, 2, and then add this 3 on to the previous list to make it into a complete list. Okay, and then what we want to do is just reduce the lists, and we'll just reduce by just keeping the biggest one, and then we start at the beginning, we start reducing, and we'll stop at the end, and whatever was the biggest, the first, will win. Okay, let's try to do this. So we are going to define a function called long sequence, and it will take in the argument s for sequence. Okay, and for now let's just return s. Let's define our test cases, and we'll define our function, and then we can map that across. And for simplicity, let's just start by working through the first one. So we'll do long seq on the first of our test cases. Okay. So the first thing we want to do is break it up into pairs. So we'll call partition, and then we can do step size, or n equals 2. It's going to be pairs, and then the step size will be 1. So that we're taking 2, but only increasing our step by 1 every iteration. Okay, I'll pull in s here. Now we can evaluate that, and we can see let's see, a sequence here, define our function, and try it out. There we go. So now we have our pairs that step through there. 1 and 0, and then 0 and 1, and then 1 and 2. Okay. So that's good. But what we want to do is we want to take those, we want to group now these pairs into pairs that are increasing. So what we want to do is we want to partition by, we're going to partition by function that inside of there, position 1 and position 2, we want to position, we want to say that P2 is greater than P1 inside those sublists. Okay, let's try that out. Okay, there we go. So we have 1 and 0 is a sublist, then 0, 1, 1, 2, 2, 3 is a sublist, then 3, 0, then 0, 4, 4, 5. Okay, so now we want to, out of here, put these into proper lists again. Now we sort of have them delineated with the one problem that we need to take 0 through 3 here, and then here 0 through 5. So what we will do is, basically what we want to do is map first across those. So let's sort of find our way through here. If we map the first function across that, what do we get? That gives us function. If we do F first, oh, sorry, my parentheses are out of whack. Put that in the wrong place. Okay, so we need close that off. Okay. There we go. So now we have 1, 0, then 0, 1, 3, 0, 0, 4. So that's not exactly what we need. We want to reach into the inside of there and grab the next first. That's not exactly what we need. So let's think about that. What we want to do is we want to map a function where this for each one of these sequences, and then inside of there we're going to have an A and a B, and we want A out of that. Let's try that out. Not exactly what we're looking for. Maybe it's nested one more time. No. Okay, I'm getting confused. So what I did to solve this before was, let's just pull out a specific case. We'll just take the second one. Alright, if we leave this part out, you just run here. The interesting case here that we're trying to work to is the second in this sequence. So let's run the second here. And that gives us 0, 1, 2, 3. So let's work on that. So when we have that, what we want to do is we want to map first across that. Okay, and that gives us that. And then the other thing we want to do is we want to get the last of the last, right? So we want to get that last 3 there. And that gives us that 3. Okay, so what we want to do is we want to conj map first, and then we also want the last of the last. Okay, we're going to have to put that as a parameter here, and then we're going to have that as a parameter. So this will be a function that we're going to call. Take that out. Alright, let's give that a try. And then since we're using the 30 macro, we need to call it there. Okay, try that again. Okay, 3102. Okay, so the only thing missing is the correct ordering. So let's change it into a vector. Into vector. Okay, 0, 1, 2, 3. So now we've got that right. Okay, and now that we have our whole function written right, we just need to map that across our sequence. So that will come in here. And now we don't need this, we don't need to call that. So let's erase that. Okay, so let's try that out. There we go. 1 0 0 1 2 3 3 0 0 4 5. Great. Okay. Now what we need to do is we need to get rid of the ones that are not increasing. Okay, so we'll filter, and we can make a function here. And we will have A and B inside of there, and we're going to filter on B being greater than A. Okay, try that out. There we go. 0, 1, 2, 3, 0, 4, 5. That looks good. Okay, and the last thing we need to do is reduce to take the first biggest list. Okay, so we're going to do reduce. Our reducing function will be say we have A and B. What we want is that we say if count of B is bigger than count A, then we want B, otherwise we want A. So we need greater than here. So if the count of B is bigger than the count of A, then B, otherwise A. Alright, let's try that out. Oh, and one thing we forgot here, looking at it, is we need our starting case, and our starting case is the empty vector. Okay, so that is working for our first test case. Let's try all the test cases now. Okay, so our first test case gave us that, and then the second one 5, 6, like we're supposed to get 3, 4, 5 in the third, and the empty vector in the last one. So I think that works. Let's make that function and copy and paste it and see what we get. And that works, so great. Thank you for watching.